Let's look at examples solving applications of systems of equations. This says the admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attended the fair? The hint here tells you to set up a system of equations where the children and the adults are represented as variables. Now, one of the most important things that I can emphasize in these types of problems is you very firstly want to define the variables, but make sure you're very specific in how you define the variables. So I'm going to use two variables here. I'm going to use the variable A and the variable C. If you'd like to use different variables, that is totally fine. Just make sure that you are defining them very specifically. Now, a lot of times I will see students write A equals adults and C equals children. This is not that helpful, and on the exam, if you write this, I will deduct you points. Why is that? Well, if you say A equals adults, that could mean so many different things. Is it the number of adults that live in China? Is it the weight of all of the adults that live on planet Earth? Is it the average age of the adults? Who knows? Because the way that we have it defined so far, it is very vague, and we need to be very specific. Now, in this particular example, there are probably two different things that you could set A equal to, and one of them is incorrect and one of them is correct. So sometimes I will see students say that A equals the price of an adult ticket to enter the fair. Now that is not correct because we already know the price of a ticket for an adult to enter the fair, and that's $4. So again, this is really important for us to define our variables correctly. Now, what is it that we're trying to solve for? We want to know how many children and how many adults attended the fair. So I'm going to define my variable A so that it represents the number of adults that attended the fair. Very specific. There's no ambiguity around what that could possibly mean. It's very specific, and we know what we're talking about. Okay. C, I'm going to define this variable to be the number of children that attended the fair. Okay, so the first and probably the most important step is we've defined our variables very specifically and very precisely. Now we want to create a system of equations by creating two linear equations based off the example that we're given above. So the first equation that I can create is based off the number of people that attended the fair. I know that in total, there were 2,200 people, and there's only really two types of people that can attend the fair. It's either going to be children or it's going to be adults. So the equation I can make out of that is that I know that the number of adults plus the number of children that attended the fair has to total 2,200 people. Now, the second equation that I'm going to be able to create is based off the amount of money that was collected. So a children's ticket is $1.50, an adult ticket is $4, and we know the total amount of money that was collected that day. So the equation that I can come up with that is $4 for all times the number of adults that attended plus $1.50 for the number of children that attended, if we add those $2 amounts together, we know that there was $5,050 collected in total. Now, I can use the elimination method that we learned earlier in this unit. And so far, the variables don't match up, or the coefficients don't match up. So if I were to subtract or add the two equations right now, neither of the variables would be eliminated. So I'm going to go ahead and multiply the top equation by 4. And if I do that, my new equation is going to become 4a plus 4c is equal to, let's see, 4 times 2,200 should be 8,800. And then my bottom equation, I'm not going to change it, and I'm going to leave it as is. Okay, now if I subtract the two equations, I'd get 4a minus 4a, and that's going to be 0. And then 4c minus 1.5c is going to be 2.5c, and then 8,800 minus 5,050 ends up being 3,750. So I'm just going to simplify that equation to 2.5c equals 3,750. And then from here, I want to get c by itself. So the last step that I need to do is I need to divide both sides by 2.5. And I'm going to throw that into my calculator. And we end up getting that c equals 1,500. Okay, so take a moment and ask yourself, what does that mean in the context of this problem? Well, if you go back up here, we know that C is the number of children that attended the fair. So there shouldn't be any question about what we just solved for, because we were very diligent at the beginning and we were very precise about how we defined our variable. So this tells us that 1,500 children attended the fair. Now, are we done? Not quite, because we still have to figure out how many adults attended the fair. So how do we go about doing that? Well, we have these two equations that we created at the beginning of the question, and you could plug in that C value into either of those equations and solve for A, but I think one of the equations is going to be definitely easier to work with than the other one, and that's the first equation. We know that a total of 2,200 people attended the event, so we have A plus the number of children, which now we know to be 1,500, is equal to 2,200. So the way that we figure out the number of adults is we subtract 1,500 from 2,200. And if we do that, we end up getting that A is equal to 700. And so normally I want you to box your final answers, and then sometimes I might even ask you for an interpretation for what you just solved for. So you might even write a sentence that says something like 700 adults and 1,500 children attended the fair. And that concludes this question.